Well, welcome back to this discussion about the law of cosines, and we're going to continue this discussion by solving some more oblique triangles using the law of cosines. And this time we're going to focus on solving side triangles using the law of cosines. So in this case, we would have no angle measures, just the three side lengths. So let's see how that works and jump in. All right, so the next type of triangle we're interested in is an SSS case where we know all three side lengths but no angle measures. And so in this case, we are going to use the law of cosines to find the angle measure opposite to the longest side length. So we're looking for the largest angle measure first. And we're doing that really to prevent any kind of ambiguous case scenarios from creeping in. All right, and then after that, we're going to use law of sines to find the measure of the two remaining angles. So here we have an example where we're given three side lengths. And we know that this is going to be a side triangle. And we are wanting to solve this triangle. So we are going to go ahead and organize our work like we did before. And then, like it says in step 1, we are going to find the angle measure opposite the largest side length. So we are interested in finding the measure of angle A. And we are going to then set up law of cosines so that we have angle A in this position. So if we've got angle A in this position, that means side A is on the other side of the equal sign. Okay, and so we're going to go ahead and sub in everything we know. And in this case, it's going to look a little bit different than with SAS. We're going to sub in our side lengths everywhere we see ABC, and we are going to end up solving for cosine of A. Now, in order to do this, we are going to need to isolate the cosine of A, and so that means pushing this 2 squared over to the left, pushing this 3 squared over to the left. So let's do that much first. So we've got cosine of A is equal to 4 squared minus 2 squared minus 3 squared. And then we're dividing out the coefficient to cosine A. All right, so divided by -2 times 2 times 3. We'll clean this up a little bit. And we've got 16 minus 4 minus 9 all over -12. And of course, to actually get the measure of angle A, we will need to take the inverse cosine. All right, and so once we simplify this numeric expression, we have the cosine inverse of -1/4, which will give us about 104 degrees. So we've got the first of our 3 pieces of information. Now again, we have a match, a pair of a side and an opposite angle where we have the information for. So now we can go ahead and use law of sines to finish this triangle. So let's do that. Set up our proportion. The pair that I have, I'm putting in the middle, sine of 104 degrees over 4. And that's going to equal the sine of angle B over 2, and it will also equal the sine of C over 3. So let's focus on this side of our proportion, these 2 ratios, and we will say the sine of angle B is equal to 2 times the sine of 104 degrees, all divided by 4. Of course, then B will have to equal the inverse sine of 2 sine 104 degrees over 4, which we will get from our handy-dandy calculator to be about 28.9 degrees. And we'll go ahead and round that to 29 degrees. And we'll do the same thing for angle C. We'll say the sine of C is equal to 3 times the sine of 104 degrees, and that's all divided by 4. And then we'll isolate our c by making that a sine inverse and use our calculator to crunch that. We should get about 46.5 degrees, which we will round to 47 degrees. Now, it's always a nice idea to use triangle sum theorem here to verify our angle measures, and we should end up with a sum of angle measures that equals 180 degrees, and we do. So that rounds up this video. The next video we will talk a little bit about Heron's law to find, or Heron's formula to find the area of an oblique triangle when all we know are the side lengths. Stay tuned and I'll see you there.